Okay, the last topic under the heading of sets is this minimum and maximum values. So what do we mean by minimum and maximum values? Usually the questions about minimum and maximum values, these are about two sets. When we say two sets, we have to consider all the possibility for two sets to be drawn on the Venn diagram. And the three possibilities for the two sets to be drawn on Venn diagram are: the first one is we have disjoint sets. Second possibility is we have intersecting sets. And the third possibility is third possibility is subset. So whenever the question is about two sets, you have to consider all the three possibilities. And how do you distinguish? There are a few things which would help us in identifying that which case is possible there for a given condition. So for all these three sets, we are considering the fact that we have the universal set represented by this E sign, and we have the two sets as A and B. Okay, all right. So first thing, we talk about this fact when we have to deal with this case. Okay, so whenever the question is about, you have to keep in mind that altogether we are dealing with three different regions there: region 1, region 2, region 3, altogether three regions there. So whenever the question uses the word, we have to find the maximum value for A union B. A union B, we have to find the maximum value. So this is the scenario to be considered. And for considering this scenario A union B to be maximum, you have to be sure that this A union B, N of A plus N of B, it should be less than N of E. Then only you can consider this case. N of A plus N of B less than the universal means whatever elements are there in set A plus whatever elements are there in set B, as a whole, their sum should be less than the universal. Then only you can consider a case of this disjoint set and to have the maximum value of A union B. And this condition is also considered when you have to have the A union B. This was the case of N of A union B to be maximum. And this case is also used when you have to have N of A union B whole complement. Whole complement means the elements outside. So A union B whole complement to be maximum. So you use the case of this disjoint set. Second thing is we are discussing the case of this subset. Oh, sorry, intersecting set. So intersecting set possibility is used when we have to have the, and yes, one more thing. Disjoint set is also used when you have intersection to be minimum. N of A intersection B would be a minimum value, and in this case the minimum value it would be a 0. So for disjoint set, the least possible value of intersection it would be a 0. Remember, disjoint set only exists when you have this condition satisfied. So this is the prerequisite. Always look for the sum of A and B to be less than the universal set. Okay, moving on for the second case where we have an intersection existing. So in this case, remember this would always be applied when you have to have the uh, condition of n of A plus n of B. This time it is greater than n of E. So whenever you have this situation, n of A is plus n of B is greater than n of E, then you go for this second situation where you have an intersection. And for this case, if you have to find the minimum value, this approach is used when you have to have the minimum value of intersection. So n of A intersection B is minimum in this case. N of A intersection B complement. In this case, this region 1 and region 3. Since intersection is minimum, that means the only part means A only and B only. Consider the fact that intersection, the common elements are minimum. So when the common elements are at minimum, the only region would be at maximum. So A only would be at maximum side now, and B only would also be at the maximum side now. And this intersection when it is at minimum. So N of A intersection B complement is minimum in this. Sorry, it's maximum in this situation. And same goes for N of B intersection A complement. A removed from B, this will be maximum in this case. And this region outside, it will be a 0. To keep the intersection minimum, remember the outside values, it should be 0. Third case, the case of subset. The case of subset is always used the case of subset, set within a set. This is always used when you have to get the maximum value of intersection. Consider the fact that you have to get the intersection to be maximum, and to have the common elements to be maximum level, the smaller set would eventually become the subset of the bigger set. So for this third case, always remember n of A intersection B. N of A intersection B, the intersection would always be maximum. N of A union B, in this case, it will always be minimum. So intersection is maximum, union is minimum, and this outside region, since majority of the elements are there inside the set A, so this outside region would also be at the maximum level. So So you can say this as A union B whole complement. This would be maximum. Okay, so these are the three different situations having the minimum and the maximum values. Okay, we'll solve a few questions that will help you in understanding the concept in a better way. So initially, this would look a bit confusing, but we'll solve a few questions together and that will help you in identifying the situation. Okay, now here, in case of this first part, we have been given that n of A is equal to 24, n of B is 10, and the universal is 32. So the very first thing to be done is to decide that out of these three cases, we first need to filter out the case of disjoint sets. Disjoint set means the very first case. And to identify disjoint, the sum of A and B, it should be greater than the universal. So n of A plus n of B, it should be greater than the universal. And in this case, we have 24 plus 10, which is 34, and that is greater than the universal, which is 32. That means we are not dealing with the first case. For first case to exist, for the disjoint set to exist, it has to be the intersection. And since the sum of the two values, this is greater than the universal, 34 is greater than 32, that means it's not the case of disjoint. So either it would be the case of small intersection or the subset. So that will decide further. Okay, so A intersection, we have to find greatest and least value of the following. So we have to find the greatest value of A intersection B. Always remember, whenever it is the greatest value of A intersection B, it will always be the subset. So for A intersection B to be greatest, I would make it as a subset. So the first thing first, I am doing it for A n of A intersection B. I have to keep it to a maximum. So whenever A intersection B is to be a maximum, it will always be the case of subset. It's a fixed thing. And subset means the outer set would be the set having the greater values and the inner set would be the set having the lesser values. So out of the two, A is having the greater value, which is 24. So A is the outer one and B is the inner one. Common elements for the two would eventually be the 10 elements of B. A is having 24. That means out of B, there would be the remainder of 14 more. And then the total is 32. So 32 minus these 24, it would be 8. So 8 would be there outside. So n of A intersection B to be maximum, it would be having the answer as 10, which is eventually the elements of the smaller set. The shortcut is whenever the intersection has to be maximum, the maximum value would be the elements there in the smaller set. And now A intersection to be minimum. A intersection to be minimum. And for this intersection to be minimum, it would be the case of a small intersection. A small intersection means this one. We don't know what is here. Always remember, for intersection to be minimum, this would be 0, the elements outside. This is set A, this is set B. A is having 24, so this would be 24 minus x. B is having 10, so this would be 10 minus x. And now you can make the equation as 24 minus x plus x plus 10 minus x is equals to universal, which is 32. So 24 minus x plus 10 minus x is equals to 32. Plus x minus x cancelled. 24 plus 10, that's a 34 minus x is equal to 32. And we get this x as 2. So the minimum value in this case, it's 2. So both these examples, or both these questions were about intersection. Intersection being maximum, intersection being minimum. So we have done the first part. Now it's about union. Union to be maximum and union to be minimum. Let's have a look at the notes. Union to be maximum and union to be minimum. So for these two cases, union to be maximum and union to be minimum. When is union maximum? Union is always maximum when you have the case of disjoint. Sorry, union is always minimum when we have the case of subset. Union is always minimum. For subset, remember, union is always minimum. And union to be maximum, it would always be the case, this one, when we have a small subset. I didn't wrote down the notes here. So for this second case, n of A union B would be at maximum. So bottom line, n of A union B, union to be maximum, it would be the small intersection. Union to be minimum, it would be the case of subset. So if I may draw these figures again. So this was the case, right? So union, first we have to make the union minimum. So n of A union B, we have to keep it to a minimum. Always remember, whenever A union B is to be minimum, it's always the case of subset. And here you can see the minimum value of union, it would simply be 14. For union to be maximum, it will always be the small intersection. And here we have already found the value. Acha, union to be maximum, remember that this outside value is a 0. And union to be maximum, since outside value is 0, A union B would altogether take the universal. Since outside value is 0, so A union B altogether, it would be equal, n of A union B would be equal to the universal. So important thing is to keep this 0 for union to be maximum. So n of A union B, in this case, it's the maximum. And the maximum value for n of A union B, it's equal to the universal set, which is 32.
Sir,
Yes.
in part 1, I don't understand this part. N bracket open A bracket close plus N bracket open B bracket close wala.
Acha, look, the universal is 32. The universal is 32. So if you have disjoint sets, disjoint set means disjoint set when added up. Disjoint set, if let's suppose we have the case of disjoint set. Do you think disjoint set when added, they should be exceeding the universal? Whatever elements are there in set A and whatever elements are there in set B, when added up, do you think they should exceed the universal?
No.
No. This is only possible when it's an intersection. Why? Because in intersection, there are elements which are being counted twice. This x is being counted in set A as well as in set B. So since x is being double counted, that is why A plus B is exceeding the universal. So in this n of A and B, this x it was being double counted. That is why it's exceeding the universal. So it's a hint that it's not the case of disjoint set. So the very first thing to be done is to figure it out whether the question is about disjoint sets or not. The disjoint set, to identify it's a case of disjoint set, this is the condition to be fulfilled, this condition. And that is the sum of the elements of the individual set, it should be more than the universal. Is it clear now? And why is it more? It's more because there are elements which is they are in the intersection, these are being counted twice. That is why individual values when added, they are exceeding the universal. Is it clear now?
Yes, sir. Thank you.
Okay. Okay, this next example. Okay, having a look at this example, can anyone tell me if it's a case of disjoint set or not? The second example. The very first thing to figure out is the disjoint set or not. So is this the case of disjoint sets or not?
No,
Sorry?
it's not.
Uh, it is. Why? Because you see, 14 are proficient in Korean and 17 are proficient in German. So N of Korean, this is 14. N of German, this is 17. And when you add them up, 14 plus 17, it is 31. And this 31, it's less than the universal, which is N of P. So that means disjoint sets are possible here. Okay. So we have to consider the case of disjoint sets as well. Unlike the previous question, disjoint sets were not to be considered, but here we have to consider the disjoint sets also. Okay, part one, the maximum possible number of people proficient in both German, Korean and German, both Korean and German. That means it's a case of intersection, and maximum means we have to get the maximum value of n of k intersection g. So whenever the intersection is to be made maximum, we always go for the subset. Which one would be the outer set and the inner set?
German would be outer, Korean would be inner.
That's correct. And the Korean elements would be there inside, which is 14. Rest of the German would be 17 minus 14, which is a 3. And all the people would be there outside. So 40 minus 17, that would be 23 here. So first part answer maximum value of n number of elements in K intersection G. This is 14. Intersection to be maximum. Second part, least possible value, least possible number of people, least possible number of people proficient in both. Again, they are talking about both. So both means it's the case of minimum value of intersection. Minimum value of n of K intersection. And whenever the intersection is to be minimum, it would be the small. Acha, wait, sorry. Uh, Intersection is to be minimum, na? And there can be a possibility of disjoint sets also. Remember, for disjoint sets, we have just learned this. For disjoint sets, intersection's minimum value can be 0. Why? Because there can be a disjoint set possible here because the individual values were less than the universal. And when the individual values are less than the universal, that means the minimum value for the intersection can be a 0. So the intersection to be 0, since disjoint set can also be possible here, so the minimum value of intersection can go up to 0. Means no intersection, disjoint sets. Third part, maximum number of people proficient in only one foreign language. Maximum number of people proficient only in one foreign language. So since disjoint sets are possible, for individual values to be maximum, that means it has to be the disjoint set. So disjoint set would give us single values to be maximum. Otherwise, only values cannot be maximum. So this is only possible when you have disjoint sets for both Korean and German. Because they're talking about only one foreign language. So only one foreign language means we'll take these values to their maximum. So 14 here for Korean and 17 here for German. This is how they can have their maximum values with the disjoint sets. So altogether 14 plus 17, it would be the maximum value of n of n of k n of g is equal to 14 plus 17, and that is 31. Okay, now this one is from the past paper. So for this question, do you think should we be considering the disjoint sets or not?
No, sir.
No, that's correct because 30 plus 20 is 50, which is greater than the universal. That means disjoint set is not possible by any means here. So we ignore disjoint set and we only focus on small intersection and subset. So these are the only two possibilities to be considered. So for part one, what do you think? Should we go for small intersection or subset? Smallest means minimum.
Subset?
Means yes. No, it's the smallest value of both Spanish and French. Subset is the case when it's the largest value of intersection. It's the minimum value of n of s intersection f, Spanish and French. So this is the case of a small intersection. S f. And for minimum value of intersection, this is always 0. This is always x to be found. This is going to be 30 minus x. This is 20 minus x. Equation to be made would be 30 minus x plus x plus 20 minus x is equals to 42. Minus x plus x cancel. 30 plus 20, that's a 50. Minus x is equals to 42. And we get x as 8. So 8 is the minimum value of intersection. Minimum value or the least value, the smallest value. You can also expect different synonyms there. Part 2. Largest possible number who speak neither Spanish nor French. Neither Spanish nor French means, in a way, this is maximum value of neither Spanish nor French. Neither Spanish nor French means this is n of s union f whole complement. So neither Spanish nor French, that means the elements outside both the sets. What do you think? Should this be the case of small intersection or subset?
Subset.
Yes. For the outside region to be maximum, it's always a subset. So the smaller value is French, which goes inside. Bigger value Spanish goes outside. French is 20. Remainder 30 minus 20, 10 comes here. And now the remainder from the universal, which is 42. So 42 minus 30 is going to be 12. So n of s union f whole complement, largest number is 12. To sum up the things, the very first thing you have to filter it out whether the subsets are whether the disjoint sets are to be considered or not. That's the very first thing. So first filter it out whether the disjoint sets are to be considered or not. If they are to be considered, you have to keep it in mind. If they are not to be considered, then keep it aside and only focus on these two scenarios, either the small intersection or the subset. And mostly in past papers, you'd see these two cases only, small intersection and subset. Uh, Disjoint set I haven't seen in last 10 years. Any questions up till here? If there are no questions, then I have a few questions for you to be solved. Guys, solve these three questions on screen. You have 10 minutes of time. Solve these three questions. If you have any problem, you can ask me. Okay, so these are all the correct answers here for the three questions given. Hope you have got the correct answers. Thanks for watching.